Hi guys, this is Mrs. Diskevich again. This time I'm going to work with you on mole conversions from going from molar volume of a gas. So we're going moles to molar volume and back, and we're going to use a constant, and that constant is called our molar volume of a gas. So this time we're in this area of Moleville and back. So the molar volume of a gas, and this is on the back of most of your periodic tables, but it's 22.4 liters per mole. So for every 1 mole of any gas, could be carbon dioxide gas, could be helium gas, could be nitrogen gas, any gas is 22.4 liters. The reason is we're looking at that volume of a gas because the volume of a gas is basically a container in which it fills. And so that gas will just, no matter how large the gas molecules are, it'll fill the container of 4 liters for 1 mole. So let's look at some problems. The first question is, what is the number of moles? Is 5.3 liters of CO2. Now we're assuming this is a STP, which unless we're told otherwise, typically we can assume STP means standard temperature and pressure. So because it's at STP, we can use the 22.4 liters. So we're going to start with 5.3 liters of carbon dioxide gas. And we're going to do just like we have been doing in our conversions, but this time we're just using a different constant. So the constant this time is our 22.4 liters. So we know we have 22.4 liters of CO2 for every 1 mole of CO2. So we're going to see when we have 5.3 liters of CO2. Now, obviously, we're going to do the same steps. We're going to multiply across, and divide the two. So essentially, we're taking 5.3 divided by 22.4, and we are going to get 0.24 moles of carbon dioxide. Okay, so that's simple. 22.4, this is like the easiest number. You don't even have like powers 10 to the whatever. Let's take a look at this one. How many liters of gas is 25 moles of O2? Now remember, we have 25 moles. That O2, what's that O2 mean? Yes, it's a diatomic. Remember, oxygen cannot be by itself. It's always looking for a buddy. So if it's not bonded to something else, then it'll bond to another oxygen because again, they're diatomic. It has no change in the number of liters for a gas. So for every 1 mole, and we're putting 1 mole on the bottom this time, so we can have 22.4 liters on the top. The reason why we put moles on the bottom so we can cancel, we have liters left. So notice since they're next to each other, we're going to multiply 25 times 22.4. And we're going to get 560 liters of oxygen. Now, yes, that number does seem large, but when we're talking about something like oxygen that's so prevalent, it's pretty typical. Let's go on to the last question. How many liters of CH4, CH4 is methane, is in 2.5 moles? So we have 2.5 moles of methane, and methane's a nice little hydrocarbon there. And for every 1 mole of methane, we have, again, 22.4 liters. Remember, we can only use this with gases. So we're going to take 2.5 times 22.4, and we get 56 liters. Again, the reason we can have moles on the bottom is so we can cancel moles and liters will not be canceled. So 56 liters of methane. So you guys try some of those problems, and we will go on to the two-steppers next. Take care.